Imagine a world without rotation, without spinning machines, without moving wheels. Modern civilization would come to a grinding halt. At the heart of every machine you use, from a dental drill to a giant turbine, lies one unsung hero: the bearing. For decades, high-level precision was the exclusive domain of Europe and Japan. But today, a revolution is happening. We are inside one of China's super factories, where raw steel is transformed into components with micron-level precision that challenges the laws of physics. This isn't just mass manufacturing. This is a war against friction. Let's dissect how China produces the high-precision bearings that are now powering the world. Before we see the fire, we must understand the challenge. A bearing must withstand loads of thousands of tons while spinning tens of thousands of times per minute. An error as small as 1,000th of a human hair will lead to catastrophic failure. In this superfactory, the tolerances used are P2 or P4 levels. That means the roundness of the steel ball is nearly perfect. If this ball were enlarged to the size of planet Earth, its highest bump would be no taller than a sidewalk curb. It all starts with the material. You cannot make world-class bearings with ordinary steel. This superfactory uses high-grade GCR15 steel with an extremely low oxygen purity level. Oxygen is the enemy. Microscopic oxygen bubbles inside the steel will become crack points under high pressure. Here, the steel is purified in vacuum furnaces to ensure homogeneous structural strength. This glowing hot steel is then forged. Thousands of tons of pressure compress the metal grains, creating a fiber flow that follows the shape of the bearing ring. This makes it many times stronger than metal that is simply machined. This is the phase where the steel gets its soul: heat treatment. These rings are heated to over 800 degrees Celsius, then suddenly cooled or quenched. This process transforms the steel's atomic structure into martensite, which is incredibly hard. However, hardness alone is not enough. Steel that is too hard will be brittle like glass. Therefore, this steel is tempered again to provide elasticity. This balance between incredible hardness and toughness is the secret why Chinese-made bearings can now last for decades without wearing out. Now we enter the most critical part: grinding. After being hardened, these steel rings become incredibly difficult to shape. Only diamond grinding wheels can sculpt them. In this factory, grinding machines work automatically with laser sensors monitoring dimensions every second. If the size is off by just 0.002 millimeters, the system will immediately reject it. Finally, there is the super finishing process. The ball path or raceway surface is polished to a mirror-like finish. Why? Because at high speeds, even a tiny bit of roughness will create heat that could melt the metal. Let's talk about the balls. Making a truly spherical ball is one of the most difficult manufacturing challenges in the world. These balls are rolled between two large iron discs with abrasive fluid for days. They grind against each other until all imperfections are gone. The result? Balls so identical that you couldn't tell them apart even with the most powerful optical microscope. In the past, China only made bearings for cheap goods. Now, look around. Bearings from these superfactories are used in China's high-speed rail, traveling at 350 kilometers per hour. Offshore, giant wind turbines use bearings 5 meters in diameter. They must withstand seawater corrosion and unpredictable wind loads for 25 years non-stop. One failure means millions of dollars in losses. Even in outer space, on satellites orbiting the Earth, these precision bearings work in extreme vacuum conditions without conventional liquid lubricants. China has proven that they can compete at the highest level of aerospace technology. Welcome to the testing laboratory. Here, dust is enemy number one. A single tiny grain of dust trapped inside a bearing can destroy it in a matter of hours. Every bearing that leaves the high-end production line must pass a noise and vibration test. If the machine detects an unusual frequency, one that even the human ear cannot hear, that bearing will be scrapped. The future of bearings is no longer just metal and lubricants. China is starting to integrate smart sensors into bearings. The bearings of the future can tell operators when they need maintenance before a breakdown occurs. This is the era of smart bearings. We are also seeing an increased use of silicon nitride ceramic materials, lighter, harder, and more heat-resistant than steel. This is the future of electric vehicles and next-generation jet engines. China's journey from a mass producer to a leader in precision is a testament to unstoppable ecological ambition. These superfactories aren't just making components, they are making the foundation for a faster, more efficient, and smoother future. So when you see the machines spinning around you, remember that there is a miracle of micron engineering working non-stop inside them. What do you think? Has China truly surpassed European standards? Write your thoughts in the comments.